Let's now start with the first thing we have, which is, and we will talk about, of course, as we all know, it is one of the types, and what is meant by the word is that you protect inside it, and generally this type of does not require neither nor even bonders, and generally this type of pro does not require teching, nor time grading, nor even time dray. Okay, now if I told you that I have a specific object and I want to protect it, I have here two very important terms, something called a protected object and something called a protected zone. The term protected object here refers to the equipment itself, meaning what? Meaning that I might have a generator motor, a transformer, and so on. Here it means that you have something you want to protect, so the protected object can be safeguarded by the means available at the head, like in my case. If I'm talking about the transformer, because if I use what's available, now I have the area between these or mine is only around. Okay, the word is a bit broader and more comprehensive. It refers to my protection area. What does that mean? It also means that if I have here a transformer here, two-side transformer, let's say this transformer is a step-down transformer converting from high voltage to low voltage. So this transformer will be connected to the GIS on the high voltage side and connected to the switchgear, which is the medium voltage side. Okay, to connect to the high voltage and medium voltage, let's say it will be connected via cables here that will enter the GIS, and other cables will go to the switchgear. So where is the location of the current transformers? The current transformer, here I have the first current transformer on the high voltage side and the current transformer on the low voltage side. As we know, from the location of the CT, your protection zone begins. So here, what does the term protection zone mean? It means the transformer plus the cables extended to the high voltage and medium voltage side, plus the circuit breakers and the section of the bus bar located inside either the switchgear or inside the GIS. Very nice. Okay, let's go. Back again, what do we have? We have, or we will talk in general terms, and then we will reflect this discussion in the upcoming lectures. On what? On the transformers, or on what we are actually going to talk about, or what is the basis of our series. Differential protection differentiates between two things, meaning you see the set of planes that exit from the set of planes that exit from... What does it mean to differentiate between two things? It means you see the set of planes, which are the planes entering your system or your system, and the set of planes that are exiting from or your system, and you start to differentiate between these planes. If the sum of the planes in equals the sum of the planes out, it means that the system is healthy and there is no issue with your comment or your zone. However, if there is a difference between the two, it indicates that there is now a path for current entering this equipment or this zone of mine, and it means there is a differential between the two. And I must start isolating the voltage in this case. So in general, we can say that it depends on what tells you that the sum of the currents in my direction equals 0 under normal EQ conditions. The sum of the currents in equals the sum of the currents out, and therefore their vector sum will be such that one, for example, is at 0, and the other at 180 degrees from the first. Consequently, if we sum them vectorially, it will equal 0. Now let's go ahead and build our electromechanical relay and construct the complete protection system. Okay, now I have a protected object or protected zone. I brought two current transformers, placing one at the beginning of the zone and one at the end of the zone that I want to protect, which is here in the middle, the object plus circuit breakers plus the part of the bus bar located inside the JSW switchgear. Okay, I have a set of requirements or considerations that I need to be aware of. What are these requirements? Number one, you need to have these current transformers with the same ratio. What does that mean? Meaning that if I tell you now that the current passing through yours is 1000 amperes, you cannot use two different ratios and start comparing their currents. What does that mean? If I tell you here I have 1200.1 or 1500.1, and here 2000.1. And the current passing through theirs is 1000 amperes, then how? Their currents in the secondary will inherently have a difference, and consequently, your protection system will consider that you have a fault. While the actual currents running in the equipment as primary are fine, with no issues at all, and no difference between them. Therefore, here you must use current transformers with the same ratio. Otherwise, you use matching cities to ensure that the currents in the normal case are equal to each other on the secondary side of the current transformers. Very good. Okay, the second thing is that you must have the same core class, and this is a must. What does must mean? It means it is necessary. What does must mean? It means there is no other solution. You must do something like this. So how do you do it, or what is the city core class in the first place? Of course, as we all know, any current transformer has a primary and a secondary, and between them is the core, which is a low reluctant material through which my flux passes. Of course, we know that we have two types of cores, the metering core and the protection core. Let's talk about the protection core. Its class determines two things for you, or rather, the manufacturing and use of this core determine two things. The first thing is, and the second thing is, therefore, if I now use two different ones, for example, if I tell you this and that, for instance, now, you have two sides that are different from each other. Consequently, there will be a difference in the reflection of currents as a result of this. Okay, you might say to me, even if I use this 5B20 and that 5B20, still the sets, even if they are from the same manufacturer or tambu, won't be identical, and there will have to be differences between them. I would say you're right, but let me show you a very simple piece of information. We mentioned it before in a video dedicated to current transformers, and I will show it to you now on the screen. You can refer back to it when we talk about the classes of current transformers. The 5B20 means that the ratio arrow will not exceed 1% at the rated current. That's right, at your rated current. That's right, at your rated current. Okay, here when you say 1% and here also 1%, this value is somewhat large. Now, if we take another class like the PX class is the customized protection core where you provide all your specifications. It is not related to any. The important thing is that it tells you it will not exceed plus or minus 0.25%, which is very nice. The more you reduce the error, you are talking about 0.25%. So no matter the difference between this and that, the difference remains in a very, very, very small area. That's number one. That's why you usually find in stations that what is used in them is a transformer. It is usually a PX class. Is that clear? Or we can even get something of a higher class than that. Okay, the second thing is that mine must be up to the current transformers to some extent. Identical. What does that mean? It means that none of them should experience something like, for example, when does it happen? Not before 20 times. Oh, yes, if it was connected. While 10 by 10 or 10 by 10 means that I guarantee you that the 60 does not enter the saturation phase before 10 times the rated current at the rated burden if the rated burden is connected to the secondary side of the 60. Okay, here you are telling me not before 20, and here you are telling me not before 10, meaning not before 10 if it happens at 15, you have no problem, but the one not before 20 will happen above 20. So, is it logical that when a current passes, for example, 12 times, 13 times, it will enter into this? Of course, it will not enter yet. And therefore, the wave of this CT will be distorted. And therefore, it will happen to you. And this is not correct. So mine must be 1. And they both should have the same. And both. The same ratio error, or the ratio error of this core is in a very, very, very small limit. And therefore, if we are talking about a simple error, between the two parties, we won't feel it. The last thing is that you need to ensure that you know whether yours is visible or not. And this is a very, very important point that we encounter in some stations, especially if, for example, an old station might have been there, and you are dealing with a new station and so on. So you start to notice the presence with be careful because you either start to reverse these wires to make, or you change the specific one. But of course, that's something we won't discuss now because it's specific to. But here, if I'm talking about what it refers to, then here I need to do the... Indeed, you should carefully consider each step specifically in this context, as a matter of fact. For instance, in this case, as mentioned earlier. Or that I connect in a certain way. Okay, very nice. Let's start talking. Here we brought, and these two have a complete nice... In this case, what do we start doing? We connect the similar ends of each with the other. Meaning I will connect like this, that the internal ends that look at mine are connected together, and the external ends are connected with each other. And then I start to connect mine, which is in the middle between mine, in the middle between the... And therefore, if I have, as you can see, my local current passes in this direction and exits from the other side. Of course, here I am not talking about a specific device. I'm not talking about a line so that no one thinks I'm talking about local and remote meaning line or something like that. No, I'm talking about having a local and a remote regardless. I named them like that based on having... Okay, in this case, according to the subtract polarity, the current in the secondary moves in the opposite direction to the primary current, and similarly on the other side. Therefore, as long as these currents are equal, and there are no differences between them, they will continue to circulate around each other without anything entering my protection relay. However, in the case of a difference between them or the presence of a fault within my protection zone, in this situation, only the differential currents between them enter the relay. In other words, I can say that generally, the relay operates on the difference between these currents or the sum of these currents in terms of direction. So, how did they make this relay? Quite simply, they brought your magnet and connected it. You see the word relay here. It refers to the coil that we have placed here, which carries the sum of the currents in terms of direction. And they placed your rotating disc here, on which one end of your contacts is fixed, and the other end of your contacts is fixed on this pivot. Therefore, when currents pass through here, it will start to become magnetized and start to rotate your disc so that they touch each other. And then your system will operate. We need to pay attention to a very, very important point. The word means that if there is a fault in my zone, it is necessary to disconnect both circuit breakers located on either side of my zone. We need to be aware of this part, meaning I don't just trip one specific breaker and assume that the currents are moving in this direction towards the fault. No. I disconnect both circuit breakers because I am unit protection. Very well, here we found some problems that we faced during the normal operating conditions. Let's take a look together. The problems we encountered with the Merz price system are as follows. Number one, it was mentioned that in the case of no load and light load conditions, we found some issues occurring. What are these issues? It was stated that in the case of no load, it means you have closed the circuit breaker on one side and opened the circuit breaker on the other side. And the term light load means that both circuit breakers are closed, but the load is very low, for example 5 to 10, with a maximum of 120% of the full load of your equipment, and it is a small percentage of the full load of your equipment. In this case, I find that in some aircraft, like the cable, there are aircraft drawn to charge the capacitors of the cable. This means your cable, as you know, is a conductor trying to insulate it, buried in the ground. So it's a conductor, insulator, conductor, which means capacitance. Capacitance is drawn, and of course capacitance is equal to between the conductor and the small conductor. The capacitance is high, so it starts to charge your charges, and it begins to pass through it, of course, because it is 1/2. In this case, it is low, so it starts to draw a set of what will be read from one side and the other side will not read it. This means that I have between the two ends. Additionally, if you have an inline transformer or if you are protecting equipment like the one called a magnet, then you have the magnet also being drawn from one side and not the other. Additionally, during this light loading, the signs of the city ratio error will start to appear. In this case, relying on Kirchhoff's current law, which states that the vector sum of currents is 0, is incorrect. Or in other words, it will require an adjustment from me. If the vector sum equals 0, it will need modification, and I can't apply it in this way. So what do I need to tell it? I need to tell it, no, I will let the relay operate, but at a slightly higher current value. Why higher? Because I expect that in my setup, there will be some discrepancy between my components, which are the result of cable charging current, magnetizing current, and the set ratio error. Let's assume, for example, that I will set the vector sum to trigger when it exceeds 0.2. Is that clear? What do I start doing? I start operating. So how will this be implemented? It comes here on the rotating disc and is connected via a spring. And this spring has something like a screw or a bolt. What do you start doing? Depending on the tension of the spring, it gives a certain opportunity so that it holds your disc and it doesn't rotate unless a current of 0.2 passes here to provide a force greater than the force of what? The BM spring. Okay, great. You said I solved the problem. He said, no, why didn't you solve it? He said, well, because in some cases these currents are still being added, meaning they increase more. Like, for example, I'll give you a simple example. Remember when we used to say, what does this mean? It means you don't exceed 5%, 20 times the current, but only at 1%. So the meaning is like that at 1%. And as it increases, it will increase for you, but it won't exceed 5% at 20 times the watt. At 20 times the current. So I expect, of course, regardless, I'm not using it, but I'm explaining to you how the idea works, right? So I expect, or I know that it will increase with you, right? Gradually. Therefore, I need to make another adjustment and start to make the collective pitch of the aircraft equal to my direction instead of leaving it. And here, I start to do what? Increase the tension of my spring. Okay, keep in mind that here we move from the green zone to the yellow or orange zone, and then we move to the red zone, which is when you have a heavy load or an external fault condition. Here it increases significantly, plus there's a possibility of having one, even if both were due to the passage of high currents of this. So in this case, there will be a significant change between mine, and let's also assume that I change mine from 0.2 to 0.8 and from 0.8 to 0.2 by also tightening my spring more strongly. That's nice. Very good. Okay, in this case, as you can see, I changed from 0.8 and from 0.2, from 0.8 and from 0.8 to 2. I keep increasing mine. So what's happening here is that I'm losing mine. This means that there could be something happening between the two sides, but with values small. And as a result of you increasing yours, the one you have won't see it, and nothing will happen, and therefore the idea wasn't really strong enough. That's why we move to the next step, which is this bias, the differential configuration.